See about your star delta transformation problems. So in the previous example, that is in the previous video, we had seen how to convert a star to delta and delta to star conversion. What was the formula there? Now we'll go for your again star to delta problems there. So here this is the network. We want to find out the equivalent resistance between A and B in the given network. So if I want to find out, either I have to reduce your top. So if I'm going to have, I can reduce the circuit there. So these 2 points are going to be the same point. So that is nothing but the same point. So I can redraw the circuit as your 6 ohms. Here I am going to have your 8 ohms. And here I am going to have your 4 ohms. Okay, now this is going to be a delta network. This delta network, so here I will be having your 4 ohms here and this is going to be your 8 ohms. So here this delta network, if I convert it to star, how it is going to be is, you are going to have a star network like this. So this is your B point, this will be your 8 ohms, this will be your 4 ohms, this is your delta network there. So now here I will be having my 4 ohm resistance there. So these two resistance are series, these two resistance are series, then this will be in parallel, then these two will be added up, the total resistance added up, I will get the equivalent resistance there. So this is how we have to do it. First, by seeing the circuit, we have to observe whether there is delta to star. So if I go to the top star to delta network, will it be of advantage? That will also, I can consider the top delta network, that is this part of your delta network also I can consider there. So your RA is equivalent to, if I convert your delta, the formula is nothing but R, whatever is going to be the delta network I am going to have. So delta what I had was, so here 6, 8 and 4. So here in this case, you are going to have your 6, 8 and 4. So here this is nothing but your B point, this I will have it as your C and this I can have it as D. So if I want to find out your equivalent like this, that means this will be your RB end point, this will be your RD, this will be your RC. Now to find out these three ends, so C, D, B. Now if I want to find out your RC, so here they are taken it as A point. So A point is, so if I am going to take this as A point, the resistance is going to be, so RC, as my formula is going to be RC, RC is nothing but 6 into 8. So this resistance RC is, to this node what is connected, 6 and 8. So 6 into 8 divided by 6 plus 8 plus 4. So we have 2.66 ohm. RB is, that is your RB here is 8 into 4 divided by 8 plus 6 plus 4, that is 18. That is nothing but 1.77 ohms. Next is RC. So now I have got the equivalent circuit. These two resistors are in parallel. So series, these two resistors are in series. So simplify it. I will be getting an equivalent to be 6.66 and here 9.33. Now these two resistors are in parallel. So equivalent resistance is going to be 3.88. Now we can see that all these three resistors are connected in series. So it is R1 plus R2 plus R3, that is nothing but 9.65 ohms there. So now to determine the resistance between the terminals M and N of the network shown in below using your star to delta network. So in this case again if we see the circuit itself simplifies, tells that we have a delta network here. Convert this delta to star. So if I convert it, I am going to have RA, RB and RC. So to have this RA formula, so to this node RA I have 20 and 8 there. So 20 into 8 divided by summation of this resistances 20 plus 8 plus 15. So it is nothing but 160 by 43. So similarly RB is nothing but 20 into 15 divided by 20 plus 8 plus 15. So it is 43, we are going to have 6.98. So RC is 2.79. Redraw the circuit. So if I redraw the circuit, how is the circuit going to be simplified? You are going to have your 10 ohms. This is your star network. And now I am going to have these two resistance series, these two resistance in series, these three resistances in series there. Now I cannot take because I want across m and n, so I cannot add this. I'll have it as such. Now if I add it, 10 plus 3 is 13.72, 6 plus 5 is 11.98, 2 plus 5 4.79. Now my circuit is simplified like this. 10 and 5 are also in series there. So now between m and n I want. So between m and n I want means what I can do is I can convert this circuit I can convert. So that is 15 and 4.79 are going to be same. That means again this is going to be a delta network. This is your delta network there. So this delta network I am going to take 13.72, 4.79 and 15 ohms. Convert that to star. So if I convert it, so the formula is going to be what? Your RA/RB plus RB/RC plus RC/RA divided by 4.79. So I will be getting here 6.14. So convert this delta to star and redraw the diagram there. So M is going to be 6.14, AB is going to be your 1.96 and 2.14. I have 11.98, 25, here 30. Now all these three will be connected in series. Now these two resistors are going to be connected in series. So it is going to be 1.96 plus 11.98 plus 25 is going to be 38.94. Down it is going to be your 32.14. When these two resistors are in parallel, so if I am going to find out the equivalent resistance, it is going to be 17.6 ohms. So your total resistance is going to be 23.74 ohms there. If it is between m and n, I should not exchange this m and n values. I should keep those 2 points as such, and remaining points only I have to alter and find out the values there. Next is compute the resistance across the terminals A and B of the network, which is going to be shown in figure below using star to delta. So using the star to delta transformation means here in this case I want to find out across AB. So across AB means I have to simplify it. So if I cannot take this delta connection because here this one element is going to come. That means I have to take this star connection. So 6, 6, 6. So if I have that star connection, if I convert it to delta, it is going to be 18, 18 and 18 there. So redraw the diagram there. So when I redraw it, I can see that this 18 and this 18 are going to be in parallel, and this 18 and 54 are going to be in parallel, and this is 18 here. So if I reduce it, it is going to be 9, 18 and 18 here. So this 54 and 54 are going to be in parallel. If I find the equivalent resistance, it is going to be 18 ohms. Now these two are going to be in parallel. So parallel means it is going to be 9 ohms there. So now I want the resistance across AB. So these two resistances are going to be in series, that is 18 ohms. So if I find out the equivalent resistance, it is nothing but 9 ohms there. So 6 equal resistors, each of 4 ohms are going to be connected as shown in the figure. Find the equivalent resistance. So if I think here in this case, these 2 points are going to be the same point only there. So the star network, if I convert it to internal star, if I convert this internal star to delta, so this internal star, if I convert it to delta, I will be getting this circuit there. So here in this case, my circuit will get simplified like this, and I want to find out 6 equal resistors. Find the equivalent resistance between two corners, between AB or between BC or between AC. So now this is the equivalent circuit. If I want to find out between AB means these two resistors are going to be in series. So 3 plus 3 is going to be in series, so totally 6 ohms. So why we are going to say is here like this. If I am going to assume how you say the two resistors are in series is if same current flows through the resistors, it is series. Okay, here I am going to have the current to be entering. Two branches I am going to have, current is going to get divided. This current goes like this. So if I am going to take this I1, this is I2, and this current comes like this. It goes to this branch also. So same current I1 only flows. If same current flows through the branches, then we say that it is going to be the resistors are in series. So 3 plus 3 is going to be 6. So now these two resistors are in parallel. That is nothing but 2 ohms there. Their equivalent resistance. So here the next problem is in the network shown in figure below, the number represents the value of the resistances in ohms. Find the resistance between the point A and B. So now if I observe the circuit, we have a delta network here. So this delta network, if I convert it to star, I can have it as like this. So here in this case, this 4, 4 and 4 is going to be a delta network converted to star. So I'll be getting like this. Now these two resistors are in series. So added up, I'll be getting these resistors like this. Next again, this star you convert it to delta. If I convert it to delta, my circuit is going to get simplified as like this. Now these two resistors are all in parallel. So parallel means now across this A and B means these two resistors are series. So it is nothing but now these resistance are in series there. So 5.87 in parallel with 11.674. So now we can see that we can have a resistance to be in parallel there. So we are going to have a 5.87 into 5.87 here. So it is 3.913 ohms there. Next is obtain the delta connected equivalent of the network. So I want to find out the delta connected. So if I want to find out the delta connected, what I am going to do is first I am going to create the star network, convert it to delta. So here in this case, we are going to take your AC sources. So AC sources, whenever I am going to take, I should do your, if I want to multiply it, so here Z1 is equivalent to, if I am going to have Z1 is equivalent to R1 phase angle theta 1, Z2 is equivalent to R2 phase angle theta 2. If I want to multiply Z1 into Z2, what it is nothing but your all the phase should be, magnitude should be multiplied and phases should be added. So Z1 plus theta 1 plus theta 2. Your phase angle should be added and your magnitude should be multiplied there. So here I am going to have this formula, I am going to substitute it. The phase angles I have to add it up. So it is going to be 0. This I have to magnitude, I have to multiply it. So here in this case 10 phase angle minus 90, 25 phase angle 90 divided by 5. So minus 90 means it represents minus j. So minus j10 plus 12 plus j25 there. So if I have, it is 2 plus 3j. So now ZAB I got, then I have like this ZC dash and ZC dash I am going to have it there. So convert it to delta, these two are going to be in parallel. So simplify it, I will be getting this delta network there. Thank you.